everybody. I'm Robin Carhart-Harris. I'm pleased to be with you this afternoon, your end, evening, my end. So I will be presenting a slide deck on the mechanisms of action of psychedelic drugs. It's going to be a multi-level talk. It will start at the molecular level, at the receptor level, the protein level, if you want, where the drugs themselves are binding and where they're first working. And then moving up to the population level, looking at oscillatory activity in the brain, groups of neurons, their electrical activity moving in synchrony, looking at circuits and brain networks, mapping that onto phenomenology or the lived subjective experience with psychedelics, and then tying this in with application as well, specifically psychedelic therapy and its various potential psychiatric applications. I won't necessarily do it in that order, might be a bit jumbled here and there, but that's the gist of where we're going to go in this talk. So let's begin here, the basic pharmacology of classic psychedelics. So I like to move towards a crisper, more precise definition of psychedelics by focusing on the classic psychedelics. So the definition I'm moving with here is that all classic psychedelics have direct agonist properties at a certain serotonin receptor, the serotonin 2A receptor. Serotonin is a very complex neuromodulatory system. It has a broad range of different receptor subtypes. Receptors are like locks, and the drugs or the neurotransmitter itself, the natural drug if you want, is the key. So receptors as locks, the chemicals coming in as the key, as the keys, and these locks are different. So with the serotonin system, there's at least 14 that have been identified, and as they're unlocked, those locks and stuff happens. The range of stuff that can happen is quite broad. Certain receptors can initiate downstream effects that are sometimes the mirror opposite of another receptor of the same type, of the same neurotransmitter system. So serotonin receptor, yet for example a 1A receptor might do something diametrically opposite to what you get with the serotonin 2A receptor activation. So the receptors that are most important, critical to the action of classic psychedelic drugs are the serotonin 2A receptor subtypes. And we know that this receptor is critical because if we look at the affinity, the binding potential of a psychedelic drug, and there's a range of them. We can think of, for example, some classic psychedelics. Mescaline, relatively weak affinity for the 2A receptor, still a direct agonist, still stimulates that receptor, and stimulation of that receptor is thought to be key to the action even of mescaline. But mescaline has a pretty low affinity, so you need about, give or take, close to 0.5 gram of mescaline for it to have its characteristic psychedelic effects. If we take another example at the other extreme, very high potency psychedelic LSD, very high affinity for the serotonin 2A receptor, and psychoactive in very small doses, around about 15 micrograms or so a microdose. So this is where we are, the affinity correlating very strongly, remarkably strongly, with affinity correlating with potency. So that's good evidence that was discovered in the mid-1980s, Richard Glennon. Since then, a key finding from Franz Vollenweider was that if you were to pre-treat with a serotonin 2A receptor antagonist, so these don't stimulate receptors like agonists do. Agonists stimulate, antagonists block. So for simplicity's sake, I refer to antagonists as blockers. So you take a serotonin 2A receptor antagonist or blocker, you give it before you give the psychedelic. It's bound to serotonin 2A receptors, it's blocking them. Psychedelic comes in, it can't get to those receptors because they're blocked. People don't trip. And so that was a discovery by Franz Vollenweider in the late 1990s, since widely replicated in a bunch of different human studies with psychedelics, animal studies too. They don't show the animal behavioral indices of tripping, head shakes, for example. More compelling evidence. You block the receptor, you give a psychedelic, and you don't trip. So critically important, these receptors. You can see where they're expressed in the brain in this nice PET image, positron emission tomography. And the hottest colors are regions where there's the densest expression of the serotonin 2A receptors. First thing to note is that they're highly expressed in the cortex. Cortex means bark, like the bark of a tree. You can see this outer cortical bark like a giant redwood, full of 2A receptors in the core of the tree, the blue there, not much 2A going on in the hippocampus and in the thalamus and putamen. So this is very much a receptor that is in that aspect of brain that humans have so much of, with our massively expanded cortex relative to our nearest evolutionary neighbors, the chimps, about 3 times as much cortex as the chimp, and massively expanded brains, particularly for our body size. Now, the cortex of a human is especially expanded in certain regions. So the unimodal regions, like the visual cortex and the motor cortex, not so much expansion from primates up to humans, but it's these high-level association cortices that have undergone the largest evolutionary expansion. And conveniently, perhaps hint, the 2A receptors are localized to those very association regions, those transmodal, transcending mode, those transmodal regions of the brain is where you get those 2A receptors, those bits of brain that are especially, and those bits of cortex that are especially expanded in the human animal. Show another finding that drills home really like a hammer blow for the importance of the 2A receptor, serotonin 2A receptor, for the action of psychedelics, is that if we look at the proportion or percentage of available serotonin 2A receptors that are occupied by different doses of a psychedelic, in this case psilocybin, then we see that correlates with the intensity of the subjective effects of that dose of psilocybin. So, for example, if you give quite a big dose, 20, 22, 25 milligrams plus of psilocybin, then you get about 60% occupancy of the available serotonin 2A receptors, and you get quite intense subjective effects. There's also this interesting kind of kink in the relationship or inflection point where you go over a certain proportion of occupancy and the experience seems to leap up quantitatively in intensity. And it's probably no coincidence that it's around about the 60% occupancy range that we achieve with the doses that we're working with therapeutically when we're doing our research with psilocybin therapy for things like depression. So around about 25 milligrams is becoming the gold standard for a big psychedelic experience that we're using to mediate therapeutic outcomes. So the next natural question is, okay, so the 2A receptor is important. What does it do? What does it do? We know where it is. We know it's important. So what does it do? And here the take home, the short story is that the 2A receptor promotes plasticity. Plasticity in itself can be broadly defined as the ability of a system or property to change. It's used in genetics as it is in neuroscience, and where plasticity can be the adaptability of a given phenotype or property of an organism. And so let's treat that phenomenon, plasticity, in a broad sense. Neuroplasticity is one aspect of plasticity, the ability of neurons to change. And first of all, we know that serotonin system itself and the 2A receptor in particular have been strongly and broadly implicated in the promotion of plasticity. And then we can be a bit more specific. We can look at markers of neuroplasticity. We can look at synaptogenesis, so the growth of new aspects of the neuron that are involved in communication. These synaptic boutons. This is a schematic, but recently demonstrated with a range of different psychedelics and also ketamine, that these components of the neuron involved in communication, these synaptic components are essentially growing after exposure to these different psychedelics. We can look at other markers like brain-derived neurotrophic factor, BDNF, and see that it's doubled, its density is doubled in the cortex. It seems to be a cortical effect with the psychedelics, and again, just a reminder that that's where those key serotonin 2A receptors are anyway. But it's not a rule that seems to hold up so strongly outside of the cortex. So in the hippocampus, for example, there isn't such clear evidence of neuroplasticity with psychedelics. We can look at brain development, a period of particularly high plasticity and learning, and the involvement of the 2A receptor there and evidence supporting that. We can look at learning itself, particularly low-level learning, association learning, learning rate, and we can see that it's accelerated by exposure to psychedelics. In this case, this is research in rabbits. LSD is given, and the learning rate, this is conditioned responses to an aversive stimuli, air puffs into the eye, and that's sped up with exposure to LSD and slowed down with exposure to a serotonin 2A receptor blocker. So learning and learning rate appears to be enhanced by 2A receptor stimulation, consistent with a plasticity effect. And then we can look at behavioral phenomena like cognitive flexibility, the ability to reverse one's behavior or thinking in response to environmental cues. The opposite of that would be to perseverate or rigidly keep on with a certain behavior. That seems to be promoted by serotonin 2A receptor agonism, albeit in a dose-dependent way. Psychological flexibility is a higher level phenomenon, closely tied to a particular school of psychotherapy known as acceptance and commitment therapy, which has been touted now quite widely as a particularly good bedfellow for psychedelic therapy, a particularly good fit in terms of relatively established evidence-based psychotherapy, acceptance and commitment therapy, seems to invoke consistent themes and principles to psychedelic therapy around acceptance, for example, emotional acceptance, working through and sitting with problems rather than trying to bypass them or just suppress them. And that seems to be promoted. These properties of psychological flexibility appear to be promoted by psychedelics after the experience itself. Another natural question to follow: we know the 2A receptors are important. We know where they are. We know what they do, and then a sort of extended question is, why plasticity? Like, why has that evolved? What's it good for? And there, the short story is adaptability. Perhaps a aspect of the human animal that is particularly developed and advanced our ability to adapt. So here's the argument, really, that that's why we have those 2A receptors. We don't have them to trip on psychedelic drugs at Burning Man. We have them for serotonin, and we probably, this is my conjecture at least, and I've just sent round this pivotal mental states paper that you might be interested to have a read of. It's quite long, but it's hot off the press, being published and going online probably this week coming. It's Monday today. At least it is for you. It's Friday night for me. So anyway, adaptability and the interesting connection here is under what conditions does the brain engage plasticity and adaptability through serotonin 2A receptor agonism? And I'm arguing here, based on a range of different evidences, that a stressed animal, a stressed human, is more likely to engage the serotonin 2A receptor system and induce a state of hyperplasticity to aid adaptability in these pivotal mental states, perhaps states of crisis, states of particularly intense and prolonged stress, when something needs to give, some kind of change, some kind of transformation needs to happen. That's when naturally we engage a natural kind of psychedelic state, if you want. That's the hypothesis. So certain types of stress, a broad range, seem to increase the availability of the 2A receptor. Hypoxia is a particularly interesting one, given some of the use of breathing techniques to promote altered states of consciousness, and perhaps also their association with altitude as well. So shortage of oxygen very potently increases the availability of serotonin 2A receptors. So you could think of the 2A receptors as being primed by chronic stress. And then the most reliable way to naturally release serotonin is to stress an animal. So range of different stress or punishment paradigms, like tail pinch in rodents, handling, just picking them up, stresses them out. Also swim stress will potently release serotonin. And so you prime the 2A system, you primed the trippy receptor, if you want. You've stressed the animal and serotonin's released. It's going to engage that receptor, and you might induce a psychedelic-like, naturally occurring psychedelic-like state. And so in this PIMS paper, Pivotal Mental States, I cite a range of different phenomenological and neuropharmacological evidences for these states that are naturally occurring psychedelic states. The drug-induced psychedelic state is just one example of a more fundamental state of hyperplasticity, in which we are more likely to undergo some kind of major psychological change. And there's a bunch of examples. They could be crises, hitting rock bottom, they could be psychotic breaks, they could be traumatic experiences, they could be near-death experiences, they could be conversion experiences. So some of these sound maybe positive, some negative, and there's a point to that, in that the states themselves are, in a sense, outcome agnostic. They're just hyperplastic states. Probably what tends to occur in nature is that we hit these hyperplastic states during times of particular strife. And so that can be more conducive to a negative outcome. So given the plasticity one and the conditions, the adverse conditions, that might accompany a crisis, or you might just think that adversity is going to pivot you towards pathology rather than some kind of positive transformation. But think of an alternative scenario. You have very compassionate therapeutic dyad or therapist team. You're going to take a psychedelic drug in a very caring environment with beautiful music, evocative music. They're the conditions, with full knowledge that this is what you're doing, and informed consent. And then you may well pivot, out of pathology and towards wellness. So that's the model. It's very outcome agnostic. It's open to challenge, but let's see if it's a useful model. So what is the latest, more or less up to date, at least in terms of what's published on the therapeutic potential of psychedelics? There's a couple of take-homes to emphasize here. One is the rapid action of psychedelics. Another is the enduring action, superior to what you see with ketamine, for example, where repeat administration is needed. With classic psychedelics, sometimes just one administration is needed to produce, pretty prolonged positive therapeutic outcomes. Range of different studies showing improvements in well-being, range of different indications or disorders where signal has been shown, albeit in quite small-scale studies. Investments coming in, one psychedelic medicine companies now valued at well over $1 billion. Regulators have ascribed this breakthrough therapy designation to psychedelic therapy. The safety profile is positive. You could look at therapeutic index. So what's the ratio, what's the relationship between a therapeutic dose to a toxic dose? Well, if you look at a drug like psilocybin, it's a massive therapeutic index, meaning you'd have to take a ton of the stuff to get in a toxic range. You compare that with a lot of medicines where it's a much tighter, much less positive therapeutic index, and a lot of legal drugs like alcohol, quite a tight therapeutic index there, but very, very favorable with psilocybin. The qualifier, a key qualifier here is context, in that all of these studies, all of these modern studies, have manipulated context in a positive way. So yes, they've taken vulnerable people in a state of psychological distress often. That's the sort of baseline that they're dealing with. But they provide psychological preparation, careful screening first, then thorough psychological preparation. The sessions themselves involve two caring mental health professionals, typically some evocative music, eyes closed, comfortable bed, lying back, hand holding if you want it, a lot of compassionate support, and then integration work afterwards as well. So it's a very favourable, kind of optimal sounding context, and so that very much needs to be borne in mind when we think of the positive outcomes here. This isn't positive results from psychedelic use. This is positive results from psychedelic therapy, with very careful contextual manipulation. Okay, so riffing off one of the take-homes, which is the potential transdiagnostic action of psychedelics, that you'll have seen a range of different disorders listed there. Obsessive compulsive disorder, MDMA for post-traumatic disorder, depression, anxiety disorders, addictions. So this is starting to sound a little bit like a panacea. So what's the catch? And part of it is, well, it's not a catch as such. It's just that a lot of different psychopathology overlaps, and maybe there's a core common factor here that could be targeted. And a lot of people have been saying this, but not really kind of identifying what that core factor could be. People have talked about disconnection, Johann Hari, or dislocation is how Bruce Alexander's referred to it. And a lot of people have been sort of shooting around this. And I would just say, one way to look at the mind is to look at these forces a little bit like evolution itself. There's a term in evolution called canalization. It's quite an old term from the 50s, but it basically means a behavior or phenotype or property of an organism that becomes stamped in and that's resistant to environmental variation. In a sense, it's the opposite of plasticity. In fact, it is the opposite of plasticity in evolutionary science. And what I'm arguing here is that a lot of these disorders that are amenable to psychedelic therapy show this canalization of thought and or behavior. The thought and behavior gets kind of rooted, it gets kind of stuck in a particular pattern or configuration. In depression, one might get rooted into negative ruminative thinking and so disconnected from the world. Compulsive thinking, intrusive thoughts, obsessions in OCD, in eating disorders and image disorders, obsessions and very strong biases around certain aspects of how one looks, very much stuck in the head in anorexia, for example, and disconnected from the body. But that excessive, rigid control is another example of this canalization. Addictions, it's kind of obvious. You are only interested in your object of relief, whatever that might be, whether it's a drug, alcohol, for example. Chronic pain and functional neurological disorders, again, how there's a bias in the way one looks at oneself and one's relationship to body and pain. And anxiety disorders, some classic ones like phobic anxieties very much fit this model where, there's this aberrant bias that a spider, for example, is a this horrific, this cue of this very strong fear response, completely irrational, yet so overwhelming. So that's the model, and with an effective treatment, you would want to do something about this canalization. And I say it's maladaptive. If we're being compassionate with ourselves or with our patients, we would say, your symptom is trying to help you. It's kind of adaptive, but it's maladaptive. It's not really serving you. And ultimately you want to get well, you want to do away with your addiction or your OCD symptoms. And anorexia, often people, that's an interesting question. Do they want to get better? But it can be so severe and tragic and such high mortality rates in anorexia that, when one is clear thinking, getting well is where it's at. So yes, we would want a treatment that relaxes and then, through inducing a state of plasticity, provide a window of opportunity for the revision of these maladaptive strategies that are the symptoms of these various psychiatric disorders. Now, this is a switch to the acute brain action of psychedelics, but in a sense it's useful. You could think of these results as being the sort of vehicle, the mediating vehicle towards therapeutic change. This has become a popular image. I think you can find it in the centerfold of Michael Pollan's book. It's from our early fMRI work with psilocybin, where we show increase in functional connectivity or communication between regions of the brain belonging to different systems in the brain or networks. Showed a similar thing with LSD. Here we're looking at the visual cortex, primary visual cortex, and how it talks to the rest of the brain. Ordinarily, most of the communication goes on within the visual system. People have their eyes closed during these scans. Even though they have their eyes closed, when you inject in LSD, the lights go on, and there's much more communication going on between the visual system and the rest of the brain. And this effect correlated with people's ratings of complex imagery or visions under the LSD. Similar thing with DMT, shown in a couple of different ways. These regions of the brain becoming more connected with the rest of the brain, the hot colours. Now, one way to show this, arguably in a more intuitive way, is to look at brain activity in a dynamic way. So this isn't a temporal sequence. It's not that you go from number 1 to 2 to 3 to 4. It's just what proportion of time within a scan do you visit this state? What proportion of time during that scan do you visit this state? And how does that change under a psychedelic versus placebo? This first brain state is somewhat counterintuitive. Instead of a brain with no colour in, all should be coloured in, because this is a brain state in which activity is globally coherent. All of the activities fluctuating up and down coherently or synchronously in sync in the different regions of the brain. And what you find under different psychedelics, here we're looking at DMT, is that this brain state, this globally coherent brain state, is visited much more readily under the psychedelic, whereas the brain states that the brain doesn't gravitate into, doesn't get pulled into, are these high-level brain states, these frontoparietal brain states, like the default mode network and these other frontoparietal networks, number 5 and 6. The brain doesn't visit these high-level egoic states. I call them egoic for good reason, because their function appears to correlate with aspects of ego function. The disintegration of the default mode network, for example, correlates with ratings of ego disintegration. Now, this is contextualizing all of this. It's a challenging slide, but in a sense, it's the most recent one that I'm presenting. And for me, it's actually the most exciting. And part of the reason is this, the highlighted bit, that what aspect of the brain has undergone the largest evolutionary expansion in humans? Well, it's these hot colors here. This is macaque to human based on MRI scans. We have most data on macaque. Chimp science isn't really done so much these days, so there's a dearth of data there. So they use macaque. And the correspondence between this map of the regions that have undergone the biggest expansion in humans, there's this popular myth that it's the prefrontal cortex. That's a myth. It's time we did away with it. It's these frontoparietal regions in the temporal cortex. And you can see that the correspondence with the 2A receptor, even just eyeballing, is quite remarkable. And let's go through some of these other properties. This one is, if you run, hopefully a few of you are quite familiar with stats enough to know about factor analyses or principal component analyses. If you were to look at the functional connectivity of the human brain and break it down into one gradient or one component, this would be it. And so at one end of the gradient, you have the transmodal cortex, and at the other end, you have the unimodal. And this is the split, and you can see again the old pattern with the high end of the hierarchy, where the 2A receptors are and the bits that have undergone the biggest expansion in evolution to humans. We can look at connectivity length and see the correspondence there, where the longest range connections are those that are the most expanded and those that have the 2A receptors in them. We can look at between subject variation. This is a plastic system. It's not so tethered and consistent. It's more rangy, and that's shown here. And then we can look at myelination. The weaker the myelination, the less canalized, the less stamped in, the more plastic these regions are. Again, the same old, these sort of grey regions are the lighter myelination, and these are these high level association cortices where you find the 2A receptor. We can look at the decoding work of Jack Gallant of Berkeley and see the processing of abstract components of narratives being localized to this same pattern of regions. We can look at the processing of temporal windows and the longer temporal windows, again, being processed by these high-level regions. We could look at the action of DMT, and this is just one of plenty of psychedelics that show the same kind of profile. And again, there's that correspondence there. So something going on. What is it? What to conclude, what to infer from all of this is a work in progress, for me at least. But there's something, isn't there? One thing to say is that let's just focus on the top left. The regions that have undergone the biggest expansion evolutionarily are where now you find in a human brain the most 2A receptors. The most grandiose thing to speculate would be that 2A receptors have been involved in the expansion of the human brain. That's possible. A more sober and simple thing to say is that they've just accompanied the expansion of the cortex, and so have they aided it? They probably do support it in some way, and quite how they support it is a very intriguing question going forwards. Can they sort of induce a sort of turbo state of plasticity in an already plastic system? Perhaps a system that is meant to be, as a key property of it, a sort of untethered, freely roaming, imaginative system. So if ever it becomes canalized or too rigid, then that's not good. It's not really speaking to its main function. So maybe the 2A receptor functions as a kind of oil to the cogs, a kind of lubricant that keeps this system fresh, allows it to breathe, gives it some flex. I think that's an interesting possibility. The entropic brain is a principle that I introduced about 6 years ago now and have updated since. Most simply, it states that the richness of spontaneous brain activity correlates in the cortex, correlates with the richness of ongoing conscious experience. It's a simple principle, but it seems to hold up. So if you look at states of reduced consciousness with anesthetics or sleep or brain injury, then you see entropy drop. If you look at the psychedelic state in relation to normal waking consciousness, it goes up. So that's all the rule is, but it seems to be quite a reliable one. we've looked at different environmental conditions with different stimuli, and found that the biggest effect with the psychedelic, the biggest differential effect, are in conditions where there's the least environmental stimuli, which is probably the reason why typically you lie with your eyes closed when you are undergoing psychedelic therapy. It's probably something that's been intuited, maybe why many ayahuasca ceremonies are done in the dark. REBUS is another principle I introduced this more recently. I go by the phonetics here, relaxed beliefs under psychedelics. REBUS, I think, sort of works mnemonically. And it very much rests on hierarchical predictive coding, that framework that is very influential in cognitive neuroscience, psychology, psychiatry, increasingly so. So does it extend to the action of psychedelics? Well, I think it does. And the principle is that psychedelics relax the precision weighting of priors or top-down assumptions, beliefs. And that's a key property of the psychedelic effect, key aspect of the psychedelic effect. And these are just kind of cute ways of showing hierarchical predictive coding in, well, showing the Bayesian brain in action, that we experience much of the world through our assumptions here. These images imply motion based on if we see this in the world. Typically there is motion, and so we hallucinate it. It's a typical kind of optical illusion. Now, one way we can test this model is to look at top-down and bottom-up processing, and one way that we can do that is to look at traveling waves, and these have been linked recently to predictive coding. If we have our eyes closed, the direction of traveling waves, like ripples from a pebble dropped in a pond, are in a particular direction. They go from the front to the back, and you could think of that hierarchically in a top-down way, from the frontal cortex to the occipital cortex. That's what happens when we have our eyes closed, probably because there's nothing to see out there through the sensory organ of our eyes. We open our eyes, photic information floods in, and the direction of traveling waves flips bottom up from the occipital cortex up to the frontal cortex. What happens if you have your eyes closed? It's going top down, injecting DMT, the lights go on, your eyes are closed, and the flow of traveling waves switches as if you've opened your eyes. It goes bottom up. So we've shown that recently. It's really exciting. It correlates remarkably strongly with the subjective ratings. I think it's good evidence to support the REBUS model, where the traveling waves, the top-down traveling waves, can be a index of the precision weighting of beliefs or assumptions. And we could also look at hierarchical organization in the brain, and look at the principal component, for example, and see how it's flattened, it's smudged into a kind of entropic, dispersed state under DMT, well replicated with other psychedelics. So these high-level bits that are sharp, this sharp contrast that you ordinarily see in the principal gradient in the brain, is sort of smudged out under DMT as the hierarchy collapses, and there's less of a distinction between these levels, these different poles of brain function. That fits with the REBUS model in terms of a collapse of hierarchical organization. Correlates very strongly with aspects of the phenomenology like ego dissolution. So that's where we are, and right up to date is that we've just finished a 2-arm double-blind RCT comparing psilocybin therapy, 2 treatment sessions of it, with escitalopram, a popular, at least among scientists, I suppose, maybe not scientists, but clinicians, SSRI, Prozac-like selective serotonin reuptake inhibitor. People either get 6 weeks of the SSRI, or they get 2 treatment sessions with the psilocybin. Perhaps in a Q&A I could go more into details of how we controlled for different parameters in the trial, standardized them, so that the main difference was, big doses of psilocybin, 2 of those, or 43 daily doses of escitalopram. We looked at multiple different outcomes, safety and efficacy. These findings are pretty darn exciting. We've written the first draft and circulating it now. Because of a few different reasons, the results might not appear published until early next year, maybe even March, but it should make quite a bit of a splash and put things in context. How good is psilocybin therapy really? I think this study will show that. There we are. Team effort. I'd like to thank the team and those who've supported our centre. It survives. It was born from philanthropic support. It's wonderful to see the same thing happening in your part of the world. I hope to be over at some point. I feel drawn somehow to the Bay Area, but let's see. So yeah, I hope you enjoyed that and look forward to doing the Q&A with you. Thank you, everyone. In the talk that I recorded, it's a multi-level talk in the sense that it starts off with the basic pharmacology of psychedelics, classic psychedelics. So it goes in at that low level and sets a stage for thinking about how do psychedelics work. They're chemicals. They bind to certain proteins that sit on neurons in our brains, and they tweak the functioning of those neurons. And we know with quite a high degree of precision what proteins are most important for those little chemicals to bind to, and they are serotonin receptors, serotonin 2A receptors, and then that, in knowing that, I often think it's remarkable that with all the richness of levels at which you can study psychedelics. If we think of psychedelic art and philosophy related to the psychedelic experience, even how psychedelics interface with political science, or the politics and policy of psychedelics, and yet we know with a high degree of precision and reliability, if you block a specific serotonin receptor, in a sense, none of this is relevant. It blocks the trip. People don't have a psychedelic experience. And so, to track it back to that level is quite, profound in a sense. And for that reason, I think it's important to spend time at that low level, even though it might not be the level in which we can make mappings between brain dynamics and subjective experience. But that's where it all begins. It all begins at that receptor level. So it does really deserve our attention in order to understand the functioning of that particular protein and ask questions like, why do we even have it? What function does it serve? Why is it evolved? And so I tie in plasticity, I tie in adaptability, and then so in a sense that molecular level is a kind of foundation for the rest of the stuff I present, because it's a model. It's a sort of kind of foundational model on which to make sense of other things like clinical applications, even the acute drug effects in the brain imaging. none of that's relevant if it's not for an initial action at the receptor level. So yeah, that's why I go there. So yeah, some themes that run throughout are things like plasticity is a core theme, prediction coding, predictive processing. If there's any questions on that, happy to address. That's a very kind of popular perspective in psychology and philosophy and neuroscience and psychiatry, neurology, increasingly popular perspective. So happy to unpack that. Yeah, or answer any questions about our recent trial, which I mentioned at the end. So wherever anyone wants to go, you take the lead and I'll respond.
Cool. Thank you. I think we should start with the people who prepared questions. So if Sheer, Oliver, and Raina want to unmute and ask whatever y'all want to ask.
Hi. First, I would just like to take this opportunity to thank you for coming to our class today. And as a student, it's such an incredible opportunity to speak with you. And so thank you.
Thank you.
My question is on the topic of psychedelic-induced psychosis and bad trips. Also, my friends Sheer and Raina have prepared similar questions that kind of relate to my question. So in your article on pivotal mental states, figure 3 depicts a boat facing a fork in the river. The boat can go left into wellness or right into unwellness. And with that said, I've heard people like Hamilton Morris and Aubrey Marcus talk about their most challenging psychedelic trips being among the most insightful, meaningful, and ultimately the most profound of the experiences that they have had. So my question to you is, where is the line between a challenging or bad trip and full-blown psychedelic-induced psychosis? And with that said, is it possible that the post-traumatic growth following a traumatic trip can make a bad trip more beneficial than a good trip? Thank you.
That's a brilliant question. Well, thank you for asking it. It's very very nicely articulated and very, very valid question. I mean, that schematic figure 3 is a simplification, as I guess all schematics and models are. And so the point is very valid that a difficult, tumultuous, challenging experience can be particularly beneficial. And so, how do we unpack all that? One thing I would say is that the term bad trip isn't really helpful. It's sort of a carryover from maybe a bit from the 60s and the kind of culture around psychedelics. It is something that the scientists will they use that? We try and stay away from it to some extent and refer to challenging experiences because that's a more meaningful term. So I would say that part of the PIMS model is to say that if there's any intrinsic sort of valence to a PIMS, it would probably be negative. And these ecstatic states, even if they yield some kind of therapeutic breakthrough that turns your life around in a positive way, whether it's some kind of spiritual epiphany or it's not unusual for that to happen through some dark night of the soul, some really challenging lead up and crisis. So I would say I hope there's no inconsistency there in a sense that the PIMS itself, and this might speak to why, you know, animals, apart from humans, don't self-administer psychedelics in the way they do other hedonic drugs, other classically rewarding drugs, you know, like alcohol or nicotine or opiates or cocaine or what have you. You know, animals will want to stay away from that lever, you know, that drops out a little bit of drug or gives some kind of recognition that drug's been received. So you know, if psychedelics are to animals aversive, maybe, you know, you could make an argument that the PIMS itself, you know, I guess where the boat is right now, as you look at that image before it forks. One thing I said to the illustrator, that's one thing, you know, you depend on the illustrator, and it's, yeah, I said, can you make the water rough where the boat is right now? Because that needs to be depicted, that it's rough and difficult where the boat is right now, and there's something in that, in the you know, the dynamics, the heightened temperature, if you want, that is important and needs to be shown. So perhaps if that was better shown in the image, it might be a bit more intuitive that the PIMS itself is a challenge, and where the state pivots is dependent on context. So when you hear of those cases of people having, you know, challenging psychedelic experiences that are the most therapeutically beneficial for them, they probably have couched that experience in some therapeutic way. They may be prepared for the experience, and they've done some work with the content of the experience, working through insights and such like. And that's probably what you would hear if you asked them to, you know, expand on why you know it was beneficial. Is that helpful at all?
Yeah, it is definitely. And then, like, to the question of psychosis versus like a challenging trip, what would you say to that, and where the difference lies?
Yeah, I think the difference may lie in the insight, the ability to, you know, come back to a point of anchorage where you can say, you know, that was the trip, and now I'm back. And so, you know, one question would be, if people go into a psychedelic experience without having a solid point of anchorage, for example, if ego development, self-development is in a state of immaturity, then you know, is there no kind of solid ground to come back to, in a sense? That's an interesting and open question. It's something that we're looking at now as we look in our data on adolescents. We have that from our prospective survey data, a pool of people within the demographic of 16 to 24, and we look at outcomes there. And what we've found, first of all, we found that, you know, most of the outcomes are moving in the same way as they do in adults, or people at least above that age bracket, where, you know, there are improvements in well-being and such like. But one curious thing was that the usual positive relationship between ego dissolution and those positive therapeutic outcomes was lost in the adolescents. So it wasn't that it was, you know, ego dissolution was driving things in a negative direction. It just wasn't driving, you know, the positive changes as it normally does in an adult population. So that's interesting, and part of the possible narrative around that is that in order to go far out, I suppose, from one's ego, it's safer to do that if there's somewhere to come back to, if there is a degree of ego maturity, I suppose. Doesn't mean you have to come back to the same old perspective on things, but at least you can come back to something that's solid. So that, and I guess the very rare cases where you do see a psychotic disorder, not a psychotic state, because that's common. To see psychotic symptomatology in a psychedelic experience is quite common. It's a pretty good model of certain aspects of an acute psychotic state. But the critical question for safety is, those rare cases of triggering a psychotic disorder, what happened there? And so the question's like, what happened there that's different to someone having a really challenging trip, but they think it's done them the world of good? And I would say really it's the ability to frame, to couch, to integrate the experience in a way that's grounded. I think the grounding of the experience, the integration work, is essentially important. It's why we pay attention to that in the therapeutic work, and underground therapists do, and such like. But it's often something that's overlooked, and I think people perhaps who are new to psychedelics, who aren't so aware of that, don't realize the essential importance of the integration work. And so it's quite easy to, again, kind of go untethered and perhaps start entertaining, especially when the experience is so unusual, so shockingly unusual. It's easy to start entertaining magical notions, supernatural notions that are, in the domain of sort of schizotypal thinking, which might not be a psychotic disorder, but also not a million miles away from one, so that's something that I'm aware of in terms of the bioethics of psychedelic research and psychedelic medicine, is trying to help the kind of grounding of the experience. And there's a philosophical position, is it solipsism, which is that your judgment of reality and the way the world is, or the universe is dependent primarily on your experience. And so these effects where people are so swept up by the shockingly unusual nature of their experience that they now believe that well, they could believe all sorts of sort of new and more sort of left field metaphysical beliefs, but they've come to those positions from their own experience. And I'm not sure that logic is quite so watertight. And so that solipsistic reasoning is, for example, at odds with what you might call kind of consensual reality. Of course, the experiencer would say, but you haven't experienced it, or something along those lines. So I've been there, I've seen it, I know it's true, the DMT entities are real, or whatever. It's can be hard to argue with. So anyway, I'll shut up because I'm rambling a bit.
Thank you.
Hi, so my question that I wanted to pose to you kind of branches off of that, related to psychosis and the development of schizophrenia. So if the prodrome of schizophrenia could be considered a pivotal mental state, would you, in theory, be targeting those with prodromal schizophrenia with psychedelics, or would you be focusing more upon those with fully developed schizophrenia?
Well, that's an interesting question, and I mean, I wouldn't naturally say people in the prodrome are good candidates for a psychedelic experience. In fact, I might be more inclined to say the opposite, that they might be people who are especially vulnerable, where it might even be contraindicated. And another thing I would say is that they might even be showing signs of a kind of protracted pivotal mental state. I mean, what's happening in the prodrome is kind of pivotally important. And so instead of arguing for psychedelics, I might just argue for, the sort of therapeutic, the quality of therapeutic care that you get in psychedelic therapy can come in to meet the prodromal state, treating it as a sort of naturally occurring psychedelic state, albeit with some differences. And so things like trust, moving with the experience, trusting the arc, trusting the trajectory of what they're going through, trusting that it's difficult now, but it won't always be difficult. Those kind of messages, I think, could be really useful. Instead, sadly, sometimes you have someone in the turmoil of a prodromal state, and they're on the cusp, all sorts of tensions and difficulties, and then they might convert and have a psychotic episode and then be treated very badly by the system, where okay, we have a problem now, and it's how do we control and manage this psychotic patient? And instead, which isn't what you would do with a psychedelic experience. So for me, I think there are lessons in how we do psychedelic therapy that could be brought into the management or the care, rather, of early and incipient psychoses.
Thank you so much. Oh.
No worries. Another model would be to try and prevent the pivotal mental state, or to introduce pharmacologically a drug like a serotonin 2A receptor antagonist to kind of put an end to this, to the anxious uncertainty of a prodromal state. That's another model, but I'm not sure it's the model I favor, but that's kind of the dominant model, is get in there and medicate. But it's such a sensitive one, because people could easily say, well, if you don't take that opportunity to have a preventative intervention right now to stop the conversion to psychosis, then it's somehow neglectful, or it's idealistic to think you can prevent that conversion with just psychological intervention, So it's a tricky one, but it's a great question.
Thank you so much. And then my second question would relate to what you just said, how right now some people treating mental illness think of it in more of a get in there and medicate type of model. And since you're challenging that model to more of a biopsychosocial approach, what type of pushback have you received from like the scientific community in general?
Well, I never win any grants, so that's a pushback of sorts. I mean, winning mainstream funding is really, really difficult, and part of it might be that I'm not playing the game well enough. But then, the game feels rigged sometimes. It's not a game I want to play, and so I've been lucky, and I've been very lucky, and philanthropy money is a wonderful thing, because it allows you to have freedom to do the kind of research that you want to do and not have to play the game. It makes me think of I can't remember where I heard it, someone like Richard Feynman saying you can judge the seniority of an academic by how effectively they hold up progress in their relevant domain. So, I never want to be one of those senior people on grant advisory boards that are, saying no to this and that, and no, it's not what I recognize, it's not what's familiar. I don't know. So the pushback isn't that visible. It's more of maybe a sort of insidious, invisible force that makes it hard to do this kind of research via conventional routes. So getting senior support at institutions is difficult. That's why when you see things like happening at Berkeley with the Center for Psychedelic Research starting up, and similar things happening at UCSF, and Stanford have studies going, and all across America and in Europe now, there are a lot of solid academics getting involved, and it's changing. So not that much pushback apart from historically how it's been. Some people see it as kind of trivial. That's how it feels at times. And some people maybe see it as dangerous or risky. Yeah.
Thank you so much. I do appreciate your challenging of more traditional methods and exploring new options towards treatment. So thank you so much.
Hi. Thank you so much for this opportunity again. Like all my peers have said, I've got more of an evolutionary question for you. In one of your lectures, you mentioned that psychedelics have a role in flattening the enslavement of hierarchical brain structures. Do you think that the hierarchical nature of the brain has an influence on creating social environments that have strict hierarchy? Also, I wonder, in consideration of the neurological context with which psychedelics take action, if it is possible that we have evolved alongside psychedelics because they have because they ease internal hierarchical structures as to create more egalitarian, efficient, and benevolent social structures that promote group success.
Wow. Oh, fascinating question. I mean, the first part, I'm inclined to say, intuition says that there's something to that brain recapitulates worlds, or social worlds that we create, or the other way around. In fact, and that would be consistent with predictive coding, or at least the free energy principle, as Carl Friston describes it, that the brain is modeling its habitat. So it's a bit chicken and egg, though. It's like, what came first? Did the hierarchy out there determine the hierarchy in here, or the other way around? And often when you have those chicken and egg questions or dilemmas, the truth is in the circular nature of the causality, that it can work both ways. But the short answer would be to say, yeah, I think so. And wouldn't it be fun to sort of demonstrate that? And how could you? Well, one thing is to think about psychedelics flattening hierarchy in the brain and how that changes political perspective. And while that might happen in the brain in a time-limited way, maybe that's enough to get a fresh perspective about things like, egalitarian values, how we're all essentially the same and interconnected and such like. And then we can take that lesson and carry it forward post experience. So I do believe that there is a relationship there. And then the one about evolving alongside psychedelics because they confer some kind of evolutionary benefit is a fascinating one. And it's McKenna-esque, isn't it? Stoned ape hypothesis, where he said that, ingestion of psilocybin mushrooms in the plains of I think in East Africa, had led to the evolution of modern humans, or the start of it. Fascinating book. I read it quite recently. I would say the skeptic in me is skeptical, but I in the slide deck I presented, I showed that pattern of cortical expansion, and isn't it remarkably similar to the pattern of serotonin 2A receptor expression? I mean, it's striking. It's really something that needs to be written up. And so, forget about any grandiose or kind of out there speculations. It looks very likely that the 2A receptor has evolved in parallel, at least, with the expansion in the brain that has happened in humans. So the next question, would be, has it driven it? Has it actually driven the expansion? And then the other bit would be, has use of psychedelics driven the expansion? And I would say I'm not convinced that the use of psychedelics has driven the expansion. Has signaling at the 2A receptor, for example, through serotonin itself, driven the expansion? Maybe. I'm interested in that possibility, and you could think of things that are in the Pim's paper about stress and adversity and adaptability, and how that's been a sort of evolutionary pressure that could have driven this system that serves adaptability. I think that's a more feasible possibility, and there again we could return to the circular causality thing, and say it doesn't necessarily have to be so linear that 2A signaling drove the cortical expansion and the functions we're interested in. Maybe there was a bit of one leading the other at one point, and then the other leading the other at another. So the short is that, well, by the looks of it, these things evolved in parallel. So that's really interesting. And what it means, I don't think we know yet, and it's an open playing field perhaps to work that one out.
Thank you. That definitely mirrors the complexity of evolution, like your response. So
okay, good. Good.
Sweet. Well, thank you, Sheer, Oliver, and Raina for preparing those questions in advance. I think now we can, so it's already 4:44, but I want to open it up to if anybody else has any questions. Feel free to type them in the chat, raise your hand, or just hop in if nobody else is speaking. Anthony, I think you had a question if you want to start this part off.
Yeah, I have a couple questions. One, are you taking grad students? No, but two, this question is kind of twofold. It's I know that like functional connectivity it's a bit controversial in terms of like what it is and what it could actually tell us. And my own intuition is that we might be able to find changes on maybe say the receptor level that can tell us about changes in functional connectivity, or even like neural oscillations. And but I'm not sure how much if you can infer it the other way around, like if you can infer specific changes on the receptor level or the level of neurons or neural populations by looking at changes in functional connectivity. So I'm just wondering, is there anybody, to your knowledge, do you know of anybody who's working on some sort of model to link changes at the receptor level to changes in functional connectivity?
Yeah. So Morten Kringelbach, great name, Danish researcher based in Oxford. We have a paper with him on just this. So you take a map of the serotonin 2A receptor, and you add in the anatomical connectivity from DTI imaging, the tracts, and what else do you add in? Based on the 2A, you add in certain degrees of excitation, and you can recapitulate some of the functional connectivity results that we've seen from our psychedelic brain imaging work. And so people are playing with that model. You'd also find Gustavo Deco in the author list. He's driven a lot of that modeling work, and that's easier to search as well. DECO, Kringleback is a bit of a mouthful. Yeah, so that's there, and that is modeling. So it's taking data from different studies. You know, you take maps from group averaged data from, I don't know, some scans that were done in Copenhagen. Then you take some DTI data from the Human Connectome project, and then you look at the functional connectivity maps from our psychedelic brain imaging work, and so it's all meshed together. There are PET MR scanners these days, so you can actually measure in a given individual their levels of 2A serotonin 2A receptors and where they are in the brain, while running a resting state fMRI scan where you can look at functional connectivity. That technology is available at MGH and Copenhagen and London. Imperial have one of these PET MR scanners. There's probably other teams as well, but that's where I know they have them. And so there's a lot of exciting possibilities in the future. And part of it might be, based on someone's 2A density map, can you maybe make predictions about what dose of a psychedelic they would need to achieve a certain level of effects? Problem is, PET scans are very, very expensive, so that approach was probably never going to be, feasible at any scale. But what we can do is we can learn some stuff in a small number of people doing that, and then find some kind of cheaper proxy or other measure that correlates with the PET measure, and then use that in the future to predict people's sensitivity to the psychedelic.
Awesome, thank you.
No worries.
Okay, so I have a bunch of questions that I could ask, but I do want to open it up to students first and encourage that you all ask your questions before.
Yeah, please fire away. There's no such thing as a stupid question.
Okay, so maybe an easy one to get some juices flowing is what are you most excited about with psychedelic research? Like, what are the frontiers that are most exciting to you? And answer, if you could answer that one quickly, because we have one in the chat.
Yeah, yeah. Cool, yeah. Sure. Well, I think you've got Jack Gallant at your university, and I'm really excited by the decoding work. And I'd love to improve connections with him because we've tried to collaborate in the past. I don't know if any of you have done any projects with him. Put your hand up if you have, I might see. No, but you do know he's at Berkeley. I think his stuff is really exciting. And so, basically brain to mind decoding based on what you're seeing in the brain to predict what's going on subjectively is fascinating, particularly in the context of psychedelics, where maybe you could predict such things as whether someone's having a bad trip, so to speak. I use that term, having a tough time on the psychedelic, or maybe having an entity encounter on DMT. And so that's a kind of really exciting, kind of fun area of research to go into. There's so much, it's really rich at the moment. Yeah.
Cool, thank you. A question from Landon is, do you think it would be possible to treat schizophrenia in a way where you transform their state into a positive experience rather than a negative one?
Well, yeah, I do. It's just, and that that was kind of, in a sense, the unspoken, that was part of the kind of, the motivation behind that PIMS paper was, you know, is it a foregone conclusion? Is it a dead end road when someone has converted to a psychotic disorder, like a diagnosis of schizophrenia, and now for the rest of their life they're going to have it and they're going to be medicated? Or can you catch them at a pivotal point and pivot them away from that? And so the key question is, once schizophrenia has bedded in, is it still a pivotal state? It's not really a state anymore. It's a psychotic trait. You know, this person now has fixed delusions. Those delusions might change a bit, but they're detached from reality. They have their delusional belief system, and it's hard to get in, you know. And so that's, what do you do in such a desperate situation when the picture is really that they're just going to have kind of mollifying medication for the rest of their lives? It's so difficult. And I just, you know, I'm fascinated by things like avatar therapy. I don't know if people have come across that, but it's where you work with a patient with schizophrenia to create an avatar, a computer graphic, animated graphic representation of the voice that they hear, or voices, but often it's actually one particular voice that a sufferer hears. And so, and they do have some kind of idea, you know, what this being might look like. And so it's kind of part art, part science, and it's a very creative thing. You create a graphic representation of the often tormenting voice, and then the therapist can speak through this avatar to the patient. And at first it starts off with the familiar kind of tormenting abuse that you might hear, you're worthless, that kind of thing. And then and then you can interact with it. So patient can say, okay, so I'm worthless, but why am I worthless? And voice says, I just think you are, or whatever. And over time you start to have a dialogue in a way that you get to know the voice, and the weight of the torment, it changes. Basically, you sort of make friends with your voice. And so there's something about the kind of unlearning or the extinction learning that's going on in that process, where the sting is taken out of the tail, so to speak. And it seems to be effective. And I just wonder, you know, whether that process could be aided, or whether it just gives inspiration for how you could work on the deconstruction of delusional beliefs in schizophrenia, and whether you could do that with the aid of a psychedelic. I would just say I wouldn't rule it out. Conceptually, it's interesting. It's not the next study that I would want to plan to do, but I wouldn't rule it out. Yeah.
Cool. Another question from Victor, very relevant. Could you share a few tips for someone who wants to get involved in psychedelic research? How do you get started?
Yeah. Well, it's difficult to say the best way to get started. I mean, it depends what you're most interested in. So if you want to be a psychedelic therapist in the future, you want to be delivering the treatment, probably the most powerful route, the one that's going to give you the most options and give you the most kind of stature and influence would be to take the medical route and then specialize in psychiatry. You don't have to do that. I mean, you know, you could still take a clinical route, but be a clinical psychologist, and again have influence and be treating patients. The difference with the medical route is that, given that historically it's only doctors who prescribe drugs, it means you can both prescribe and then do whatever psychotherapeutic work that you want to do as well. So it gives you more options, is the psychiatry route. And if you have the time and patience, that's probably the one I would recommend, but it's a long old road. You know, you're all young enough to take it. And then the other one is, well, I'm not interested in that side of it. I'm more interested in the basic neuroscience. And then I would say, you know, stick to doing well in neuroscience and try and, when you have an option to do projects, try and get in with some people who are doing some psychedelic research. Thankfully, it's opening up at Berkeley. You know, try and get some kind of internship or you know, some kind of master's project with someone, and that gets your foot in the door and it becomes a stepping stone. And just, yeah, sticking in there. It is a hot topic and a lot of people want in. That's something that, you know, I have to deal with in a sense, in that there's so much demand to supply, and that's true on the therapeutic level as well. But hopefully in the future things will open up and there'll be courses, formal courses in psychedelic science and psychedelic medicine, in the same way that you could enroll on, I don't know, translational neuroscience or something like that. You could enroll to do a master's in psychedelic neuroscience or psychedelic therapy. So I hope, you know, with the demand being there, that the opportunities will open up as well. And nothing to say is that, as is true of medicine, where there's not enough doctors, you know, there won't be enough therapists. As this scales up, you know, psychedelic therapy could at least formally be legalized in a matter of weeks in Oregon. There's a runway before it can be accessed that might take 2 years or so, but at least on paper, it will become a legalized option in the elections. And then, you know, the other developments with MAPS and Compass trying to get marketing authorization for psychedelic therapy. There's all of a sudden, you know, the gates are going to open. This is approved now. It's a licensed treatment. Where are the therapists? Where's the training? So the opportunities will arise. If they're not here right now today, they're not so far away. So, you know, if you really want to get in, just position yourself well, and there'll be opportunities. Yeah.
Sweet. Thank you. Oh, Anthony, do you want to do the next one?
Sure. So we have, let's see. We have another question from Annabelle. She says, I believe that disorders such as depression and anxiety are where the disconnect from reality is not so much as distorted, but is exaggerated. Long story short, in the future, could psychedelics ease the symptoms?
Could psychedelics ease the symptoms of schizophrenia or of depression and anxiety?
She says depression and anxiety.
Yeah, absolutely. I mean, already the evidence is building in that direction. Our recent trial very much supports that principle. The key thing to emphasize is it's psychedelic therapy, and let's not get too drawn in by psychedelics, because it really is a combination treatment. So the safety and efficacy is in a combination with the therapy, and the therapy has to be done well. But our recent findings from our trial, where we went head to head with standard practice, being on an SSRI, the findings are really exciting and will help to contextualize things. So I have a huge amount of hope that the treatment options for people suffering from depression and anxiety will be really quite different in the near future, where there is hope, and things seem much more positive than they have historically, where things have looked pretty desperate.
Thank you for answering that question. I didn't realize that we're already at time. So if you need to go, I understand. Thank you.
It's 1 a.m. here, so and my 3-year-old will be waking me up at 6:30 in the morning or something. So
Oh my, okay, you gotta go then. But thank you so much for taking the time to speak to us. This has been really great, and the recorded lecture was very helpful and awesome. And yeah, it's been great just to hear you talk and answer our questions.
My pleasure. Remember the mantras.
Yeah, I will say that Jack has cited you in his cognitive neuroscience class.
Sorry?
Jack Gallant has cited you in his slides in his cognitive neuroscience class.
If you see him around, yeah.
I've talked with him about you in terms of my own project, trying to use his decoding model to look at what people are seeing on DMT, which there are a few problems with that, but I ended up doing a project kind of similar using his encoding model to look at tuning curve shifts with fMRI under the influence of DMT.
Yeah. Amazing. Well, yeah, hopefully more to do in that space, and yeah, some cool stuff to be done.
Absolutely. Thank you.
Yeah, thank you so much. Hopefully we can continue the relationship through our club somehow.
Yeah, and hopefully, when the world goes back to normal, if it does, I'll be able to get over to your part of the world, because that would be very nice. And that's kind of, yeah, without saying too much, that's something that interests me. So let's see.
Awesome.
Cool. Sure. Take care, everyone. Thanks for tuning in, and I hope it was interesting.